We are going to be looking at what vectors and what scalars. I'm going to introduce you to the easy ways of calculating questions on this topic. We're going to do a step-by-step approach. At the end of this topic, you will be able to solve any question under what vectors. First of all, we'll talk about a vector quantity. We're talking about a quantity that is defined in what magnitude and what direction. A scalar quantity is a quantity that has what magnitude, or a quantity that can be defined with what magnitude, what only. Vectors are usually represented with a straight line that has an arrow head. This part is called the head of the vector. This other part is called what the tail of the vector. Now, in the course of doing calculations in this topic, you are going to come across the word sum or resultants. What about the sum of two vectors or the resultant of two vectors? The resultant is the sum of what the vectors when they are taken in order. Take for example, you have a vector in this direction, let's say vector A. You have another vector in this direction, vector B. Then you have to find what the vector sum. Get the vector sum and draw this vector A. You know, the tail of vector B are attached to the head of vector A. Then the third vector that joins them to form a triangle. That vector C becomes what the vector sum. That is the vector sum, also referred to as what the resultant vector. Now, under vectors, they will give you questions. Sometimes they'll give you a diagram you have to resolve. Sometimes they'll give you the question in theoretical form. And then from there, they'll tell you to calculate what the resultants, or the resultant of vector, or the resultant of the system of forces. We are going to look at resolution of vectors. So I'm going to show you how to resolve vectors. But most times when you have just two vectors like this, you can use what is called the triangular law of vector addition. Okay, it's what is called the triangular law of vector addition. We have the parallelogram law of vector addition. So if you have two vectors, A and B, you have a vector A, you have another vector B, separated by an angle theta. Then you have to find what the vector sum. There are two ways of doing this one. You can use what is called the triangular law of vector addition, or you can use the parallelogram law of vector addition. What is the parallelogram law? We just draw this one to form a parallelogram. And then we have a straight diagonal here of that parallelogram. This diagonal here becomes what the vector sum. Becomes the vector sum. Now, if you want to make use of the triangular law, you get the same thing as someone making use of this parallelogram law. You have vector A, you have vector B. If I want to make use of the triangular law, what I'll do is that I'll draw vector A again. I draw vector A. Then the tail of vector B, I'll join it to the head of vector B. And since the angle between them was theta, which is here, and I'll get what is in angle. Before then, this third line that joins them together becomes what the vector sum A plus B. So that is in angle by subtracting, because this angle here will be equal to this one here. So if here is theta, here is going to be what theta. But at this inner angle, let's say alpha. Alpha will be 180 minus what theta. Reason is because sum of angles on a straight line is equal to what 180 degrees. Sum of angles on a straight line is what 180 degrees. So with that, you can get the inner angle, and after getting the inner angle, you can get the value of your C. Like in this case here, you cannot apply the Pythagoras rule. Apply the Pythagoras rule if you have the vectors in this form, let's say A and B, separated about 90 degrees, then you have vector C. This one you can make it of the Pythagoras theorem. C squared plus A squared plus 1B whole squared. To get the value of what the resultant of vector. But in this case, we make it what is called the cosine rule. The cosine rule, so that C squared will be A squared plus B squared minus AB plus what alpha. So with that, you can get the value of the resultant of vector. Now, if you are taking the vectors in what order, and you want to make use of either the triangular law or the parallelogram law of what vector what addition. Now, for resolution, if you want to resolve vectors, you can resolve them into two components, the perpendicular components and the horizontal components. Sometimes when you have more than one vector, you can make use of what is called the polygon law of vector addition. You have more than one vector, you just join all the vectors together, join all the different vectors, then the last one that joins them to form the polygon, okay, that becomes what the resultant of vector. Take for example, you have this one A, you have another vector B, you have another vector, let's say C, okay, then you have to find what the resultant of vector, that's the vector of sum. What I'll do is just to take the vectors in order. If I draw the A first, okay, doesn't matter, I can start with A or start with B or start with C, you get the same thing. If I start with A, then I join vector B, then I join vector C, and this one that joins them together form a polygon. This one becomes what? The vector of sum, or the resultant of vector. But you can actually solve this one by resolving into two components, the vertical component and the horizontal component. After resolving, you can then make use of what the Pythagoras theorem to get what the resultant of vector in magnitude and direction. Let's take a simple example first. Let's just go to resolution of what vectors. Let's see how we can resolve what vectors. We want to resolve vectors. You resolve them in the vertical and the horizontal direction. The vertical and the horizontal direction. Resolution of vectors. We're going to make use of this a lot when solving. So, if you have a force here, plus a P, and you have an angle of theta at this point, you resolve this one to the horizontal direction, the Fx and F1. To resolve to the Fx direction, what I'll get to the P cos what theta. Moving in this direction. Then if resolve in the vertical direction Fy, we'll get P sin what theta. It's important to know how to do this one, because sometimes you have more than one word force to resolve. Okay? And then always remember what the signs. So normally, in the xy plane, this up part is positive, this part is negative, this is positive, and this one is what? Negative. So if I resolve a force in this part, let's say I have a force, let's say A, and there's an angle what theta at this point here. So I want to resolve to the horizontal and the vertical direction. If I resolve to this vertical direction, I'm going to have A sine theta. If I resolve to the horizontal direction Fs, I'll get A cos what theta. And this one is going to be what minus. And we have for the negative what sign. It's important to remember this one so that when you start resolving what vectors, when you have more than one force to resolve, it will be easier for you to understand if you can remember this plus, minus, minus, what plus. It's going to help in resolving forces when you have more than one force to resolve. So now I'm going to look at very simple examples. Okay, like I said, I'm going to do a step-by-step approach so you understand the calculations in this topic. Then our next class, I'm going to look at some more questions that will be a little bit more complicated, theoretical questions. Okay, today I'm going to solve questions like drawing a diagram for you. I'll show you how to input what the numbers, okay, in this SY plane before you can solve what questions. All right, let's take an example first. Let's take the first example now. Example 1. What is 5 Newton and 8 Newton were force? And it has to find the resultants. Find the resultants. Find the resultant force in magnitude and direction. Now, how do you do? I can decide to draw this again. I'll draw this one again. If I want to make use of the triangular law. So I have this first one here, 8 Newton. Then the tail of this one, I'll go to the head of this vector this way. So I'll get to 5. And I'll join this one here. That will be what the resultant. That will be what the resultant. So, to get what the resultants, let's just calculate the magnitude for this. The subsequent questions, I'm going to show you. Let's make this one easy first. Okay, so now, this one here is what 60. And this one is going to be 60 this way. So the inner angle here, we can obtain that, let's call that theta. Small angle on the straight line is 180. So I'll get 180 minus 160. That was 121 degrees. That was what 121 degrees. So the next thing I will do is to get what the resultant r squared equals 5 squared plus 8 squared. That's making use of the cosine rule now. 5 squared plus 8 squared minus 2 times 5 times 8 cos 120. We get 25. We get 64. This one will give us what 80 plus 120 is minus 0.5. So that this one will give us 89 minus minus is plus. If we multiply, this one will give us what? 40. Now we get R. We get R equal to, so out of this one, we get 129. That's R squared, no? Equal to what? 129. So that R will now be square root of what? 129. When you find the square root of 129, you get 11.04. That was 11.41 newtons. So this is how we make use of what? The triangular law to solve the question, the triangular and the parallelogram law to obtain what the resultant of force, which is what the sum of the two vectors or the sum of the two forces when they are taken in order. Remember, I said taking vectors in order means joining the tail of one vector to the head of other one vector. So now I'm going to show you how to resolve vectors. But before we do that, like I said, in the next class, I'm going to be showing you questions slightly different from the ones we are going to do today. And those type of questions, we need to understand how to place the direction in the SY plane. Now, if you have something like north, 60 degrees or east, so that the first F is at the point north, 60 degrees or east. You need to learn to position this one in the SY plane. We have this one. Here's the north, here's south, here's east, and here's west. So north is going to, that means the angle is going to be, the force is going to be here. Let's say F1 now. And that's the force. You have force F1 and the point north 60 degrees or east. You need to know how to position this one on the SY plane before you can actually resolve vectors. So north 60 degrees east means the angle is going to be at this point here. That's what 60 degrees would be. This one also written as 60 degrees east of north. 60 degrees east of north. Let's see another one. If you have a force F at 30 degrees north of west. We want to position this one. We're drawing the diagram. There's the north, here's south, here's east, and here's west. We have something like this now between north and west. The 30 degrees north of west means the angle is going to be here. That's what 30 degrees will be. Like I said, you need to understand how to actually write this for you to be able to solve questions later. It will help you to understand what we are going to do when we get to the part 2 of this word series. Because I may not do questions relating to this one in this particular series, in this particular class today. Then in subsequent class, we are going to make reference to this, and if you don't understand what I'm doing here right now, it may be difficult for you to follow what we are going to do in the part 2 of this class. Let's take one example. The first F at 35 degrees south of east. This one, we have north, south, east, west. We're going to have something like this. That's the first F. And the angle is going to be at this point here. So now that you've understood this, let's see how we can resolve our forces. Let's see how we can resolve forces into two components, the x and y component. Now the example 2 now. Example 2. You have a diagram like this. Here is 3 Newton. Here is 60. Then I have 7 Newton force in that vertical direction. And we have to calculate the resultant vector in magnitudes and direction. When we calculate in magnitude and what direction? When we calculate in magnitude and direction, when we calculate the resultant of force in magnitude and what direction? What we do in this case is to resolve first to the horizontal, then it can result to what the vertical what direction. Remember, this part is positive, this part is positive, here is negative, and this part is what? Negative. So if I resolve the 3 Newton force to the horizontal Fx, what I will have is 3 cos what 60. We'll have 3 cos what 60. That is the only thing we have in the horizontal what direction. Then the vertical direction, Fy, I resolve this 3 Newton force to the vertical direction. I'll get 3 sine 60 plus 7. So we have a 7 Newton force in the vertical direction, the positive one axis. So now, we'll work on that now. So I'll give us 3 times 0.5. And now the 1.5 here. This one will give us 3 times 0.866. Then plus 7. .866 times 3, 2.598. Well, we'll get 9.598. So the next thing we'll do is to get what? The resultant. We get what? The resultants. The resultants, that will be fs squared plus what? Fy squared, square root. Fs squared plus what? Fy squared. Now get R equal to Fx, we have 1.5. 1.5 squared plus Fy 9.59 9.598 squared. 9.598 squared. So is 2.25 plus 9.598. 92 points. 1, 2. So we get 92.12 plus 2.25. That will give 94.37. When you find the square root with 9.7 of 1, 9.7 of 1. Okay. So that is the resultant. So the next is to find what the direction. To find what the direction. Now you see that fx is positive, fy is not positive. So we have fy, we have fx. So that's the resultant here. So I'm going to obtain the value of this angle. But before we do that, let's get easy now on theta. This part is fy. Here is going to go fy. So here I'm going to make it of. We'll have something like this now. Fy, fx. There's 90. There's your resultant. Here's your theta. Okay? Here's north. Here's south. Here's east. And here's what? West. Now we got the value of theta now. We got the value of theta. We know what the value of fy and fs is. We know what the value of fy and fs is. So we have there's the opposite now. There's the what adjacent. Opposite to our adjacent, that's tan theta from trigonometry now. Tan theta will be fy over fx. That's opposite over our adjacent. So I'll get tan theta fy. Fy is 9.598 and fs is 1.15. 1.15. Now let's tan theta. We divide that now. 9.598. 9.598 divided by 1.5. That was 6 points. 3987. So theta will be tan inverse. Tan inverse of 6.3987. Find the tan inverse of that. Tan inverse. Probably about 81 degrees. If you approximate that, there will be approximately 81 degrees. Approximately 81 degrees. So if there is 81 now, this part is going to be 9 degrees. So this part is not 90 degrees. So this part is going to be 9 degrees. So what I will have will now be R will now be 9.71 Newton. 9.71 Newton. Yes, 9 degrees. North 9 degrees east. North 9 degrees east. So that is the value of the magnitude and what's the direction. But like I said, it's good for you to know how to resolve these vectors in this form. So how you have more than one force, you can do the resolution of vector to obtain the resultant of vector. And you need to learn how to get this direction and how to input what the value into the SY plane. That's going to help you to understand what you are going to be doing in our subsequent classes. Okay, let's take a look at another example. So I'm going to look at very simple examples today for you to get an understanding of what we are going to do. So I learn how to resolve vectors. That will be example 3 now. Example 3. Okay, calculate resultants force in magnitudes and direction. Now, I'm going to find the resultant force or the resultant vector in that case, the magnitude and what direction. For you to solve this question again, always remember this diagram. Yes plus, minus, minus. Okay? Now, the first round is to resolve the force and resolve to the resultant direction, and then I resolve to the vertical direction. I resolve to the horizontal direction, then I resolve to the vertical direction. Just like I did in example 2. Okay, let's see this one. Let's resolve now. Horizontal direction, Fx. Fx. I resolve to the horizontal, moving this force to this direction now. That's the positive direction. I'll get 6 cos 38. So anytime you move to the direction where the angle is, you have what cosine. Cos. You move to the other part where you place the angle, you have what sine. So I have 6 cos 38 for this part. Then along this horizontal, you see there's a 5 Newton force. There's a 5 Newton force in the negative part. So I'm going to put minus 5. Then for the vertical direction Fy, for the vertical direction Fy, I resolve this force now to the vertical direction. So I'll get to a 6 sine 38. And in that part, there's no other number of force along that path. So the only force I have in the vertical direction is 6 sine 38. So now we work on that now. Fx, we get the value of cos 38. Now 0.788. 0.7880. Multiply that by 6. We get 4.7. 728. 28. And subtract 5. We get minus 0.272. 0.2712. Then for the Fy direction, Fy sine 38, 0.6157, 0.6157, for that Fy 0.6157, 0.6157 times 6. So it was 3.69. 3.69. Okay, now we have the value of what Fy and what F of S. Now I have the value of F1 and Fs. I'll get a resultant, which should be Fs squared plus Fy squared. Fs squared plus Fy squared. That will give us Fx 0. Like, you can omit that 0. That's going to arrive at the same answer because the square. The square minus sign will become what? Plus. Okay? So now Fy 3.69. 3.69 squared. But I'll get a resultant equal to square root 0.272 squared. That will be 0.074 plus 3.69 to have 13.62. When you add up, you get 13.694. 13.694. But I'll get R square roots. Value was 3.17. 3.7 newtons. Now that's 3.7 newtons. That's the resultant. The next thing is for us to get for the direction. Now we go back to the SY plane. Now. So for Fy is positive. So I have Fy this way. Fy. Then Fs is what? Negative. So I have Fx this way. Because it's negative, it's going to be on this part. So the resultant. So I'm going to have this one. So now I got Fy. I'm looking for this one now. Angle alpha. So we'll get your theta first. So I draw this diagram out. Here's theta. Here's Fy. And then here's what F what S. And here's what 90 degree. So I'll make it of tan theta Fy all about Fx. Fy about Fx. Fy is 3.69. Fs is 0.2702. 0.272. .69. divided by 0.272. It was 13.5662. 13.5662. So theta will be tan inverse of 13.566. So that from there, 13.566. Thirteen point six six two, 13.5 tan inverse of 13.566. Now it was 85.8. 85.18. 85.81 degrees. 85.81 degrees. Okay, so now that we'll play this one now, we'll get this other part here. So that alpha will be 90 minus 85.8. That will be 4.1. So that you get R equal to 3.7 newtons. 3.7 newtons. There's north, south, east, and northwest. So that's north 4.2 degree west. North 4.2 degree west. So that's the resultant in magnitude and what direction. For those of you just coming across this topic for the first time, doing it for the first time, it may look a little bit more tricky, but it's not something that you can just take your time. You can play the video again, pause it at some point, and try to do these things on your own. Okay, when I write out the example, pause the video, and then solve it on your own. Then later play the video and compare the solution to see if you get it right. Okay, that's the way for you to learn what we are doing here. It's not just by playing the entire video. Okay, let's see another example. Let's say example 4. Let's see something very easy. .68 degrees, 2 Newton force. Let's say we have another force, say 3 Newtons here. And let's have 4 Newton force. Okay, if you have something like this and I have to calculate the resultant force in magnitude and direction. you have something like this. It's still the same thing with what we did before. It's still the same thing with what we did before. We use the same approach. So here we have the positive, positive, negative, negative. Now let's resolve this one. Fs direction, Fs. I resolve this one to this direction here. We have the 3 Newton force there. Resolve the 2 Newton down. We get 2 cos 68 plus, okay, it's on the negative part now. So minus 3. So that's what we have there. Then resolve to the vertical direction Fy. Resolve to the vertical direction Fy, that's this way now. We have 2 sine 68. We have a 4 Newton force along that path in the negative direction. So minus what? 4. So this one, let's see, 68 plus 68. That's 0.37. 0.3746 minus 3 is sine 0.9272. Minus 4. So that's 2 times 0.3746. 3746. 0.7492 minus 3. Around 2 times 0.9272. 1.85 8544 minus 3. So get fx 0.9272 0.7 plus minus 3. Okay. So it was minus 2.2508. Then Fy will get 1.8544 minus 4. 8544 minus 4. That will be minus 2.1456. 14506. There's minus 4. All right, so now we have the value of fx and fy. Now that we have the value of fx and fy, resultants fs squared plus fy was squared. So I will get, like I told you, you can remove the minus sign, okay? 2.2508 squared plus 2.14 56 whole square. So times the so in 5.07, and we have 2.1456. So I get 4 points, let's say 4.6. We have 4.6 plus 5.07. So I get 9.67. 9.67. The square root. Dog is 3.1. Dog was 3.1. So resultant is 3.1 newtons. So the next thing is for us to get for the direction. Now, if you want to get the direction now, you see the value of fx is negative, fy is not negative. So I'll get something like this now. Both of them negative. Okay, no, negative. So this is negative fx, and this one is negative what f of y. Okay. So we have the resultant. Then we have the angle at the median theta. So this part is taken as fy. So if I draw that part of the figure, we have fy, we have fs, we have theta, and we have what r. So now we need to get this value of alpha, or in this direction, either this one or this one. So anyone. So now the next thing I'll do is to get what theta, grab tan theta, fy all over fx. Fy over fx. Fy is 2.1456. 2.1456. And fx is 2.2508. 25018. So I'll get tan theta 2.1456 divided by 2.2508. That was 0.95. 9533. So our tan inverse of 0.9533. So I'll get the value of theta. Point 9533. That is 43.16. 43.16. So alpha will be 90 minus 43.6. So that will be 46.4 degrees. So now if you want to, let's say 46.4 plus 180, that will be 226.14. 226.4. That's what you do. The resultant, you can put it as 3.1 newtons, 3.1 newtons, 226.4 degrees, or I can put 3.1 newtons. 2 to 4 is from here down to this point here. That's it. Okay. Or we can now write 3.1 newtons in respect to this now. Here's the north, here's south, here's east, here's west. So this angle, alpha, which is 46.4. So I'm going to have south 46.4 degrees west. South 46.4. 46.4 degree west. So that's the value of the resultant. So it's not something that is difficult, okay? Resolution of vector is not something that is difficult. It's something you can easily do if you follow the simple steps, okay? Now, next class, I'm going to look at theoretical questions so you can see the reason why I was teaching how to input what the values in the XY plane. If you don't have to input the values as well as the angles in the XY plane, they are going to have difficulties in solving some questions under vectors. Okay? Try and go through this topic again to get a proper understanding before our next class. If you have not subscribed to our channel, try and ensure you hit the subscribe button, and I'll see you in our next class.